Okay, here we are, week 6. We are in module 1 still, topic 2 now, lesson 1, and you can call this kind of part 1 if you want. You're going to have some notes today and some notes tomorrow. The notes today are going to be a lot of vocabulary. If you notice on page 113, which this is, on the right-hand side, there's a lot of information, a lot of definitions, and it continues on to 114. But we're going to keep coming back to this circle that we're going to end up constructing here for number 1, and it just keeps having us build off of this circle. So even though I had you tear out a couple pages here, a lot of the notes are going to be on this front page. All right, so let's go ahead. These are notes. Okay. So notes. Module 1, topic 1, or topic 2, sorry, lesson 1. There we go. All right, so we need to get our compass, okay, and I'm going to put it about in the center here. In fact, you have to label the center point, so I'm going to go ahead and label a little center point here so that I can work off of this. Let me move my compass here first. Okay. So I'm just going to pick a center point, and then I'm going to work off of that instead of trying to kind of estimate where my center point is. All right, so I'm just going to kind of put my compass there. Doesn't matter how big. You don't want it so big that you can't see what you're writing and that sort of stuff. Okay, so have it go in there, and then I need to push this off to the side. It's not letting me delete it. There we go. All right, so we need to label the center point O. So we're going to label this O right there. All right, so then we need to, it tells us as we keep moving down here, to use the definitions to complete the constructions and answer each question. So the first thing it asks us to do is construct the diameter of the circle, label the endpoints D and M, and point O is the midpoint of the diameter. Okay, so we need to construct a diameter here. So we are going to, I think the easiest thing probably to do, we'll keep it like that, all right, is to, get me a line here, through O. And there we go. All right, and it tells me to label the endpoints D. So I'm just going to put D over here and M over here. Okay. Then it says that point O is the midpoint. Well, it's the midpoint because technically a midpoint cuts something in half. So you have this is congruent to this. All right. So midpoint is the middle point. So that means segment OM or MO is congruent to segment OD or DO, whichever way you want it to go. Another word for these is something you might know as the radius or radii of the circle. So OM is a radius and OD is a radius. All right. Now it asks, the next question here is how many central angles and arcs are produced by drawing a diameter? Well, again, here we go. All right, so we have some definitions over here. Radius of a line is from the center of a circle, this thing, to a point on the circle. A diameter, these are things that probably you're already familiar with, of a circle is a line segment passing through the center with endpoints on the circle. And a central angle is an angle with its vertex at the center of the circle. So, all right, how many central angles do we have? Well, we have a central angle right here, where we have this point, all right, coming off here. Okay, so we have this central angle of MOD, and it has a measure of 180 degrees. So the measure, there we go. All right, so the measure of angle MOD is 180 degrees, as well as the measure of angle DOM is 180 degrees, otherwise known as a straight angle or a linear angle. All right, so we're kind of talking about this angle right here. So from here out. All right. Okay. Now, they also want to know how many arcs. Well, an arc is the part that's on the outside. So it's the distance that goes around this part out here. This is the arc. Okay. In this case, it's a semicircle because it's an arc that's made by a diameter. Now, usually semicircles we label with 2 or 3 letters, right? So that means we need to get a third letter in here. So I'm just going to randomly pick a point over here and call this point X. Okay. So we have on angle DOM, we have arc DXM, which is equal to 180 degrees. Okay. And then for angle MOD, so I'm going to call MOD this bottom part down here, this arc down here, and the angle that's formed by these two sides right there. So I'm going to put a, get this a little bit in there, little point over here, and I'm going to call it Y. So for MOD, we're going to have arc, and I'm going to run out of room, so I'm just going to put it down here. We're going to have MYD. The arc is made with an arc symbol, and that's also equal to 180 degrees. So central angles are equal to their arcs. All right, and like I said earlier, what name is given to each half is called a semicircle. Okay. All right, so then it says we need to construct a perpendicular bisector of the circle's diameter. Label the points of the intersection of the perpendicular bisector in the circle as points P and B. Okay, so we need to now construct a perpendicular bisector. So I need to bring my compass back over. And I'm going to use M and O, or M and D, I mean, as my 2 endpoints. And I need to get arcs above and below. Okay, so I don't want to draw anything. I just want to get some arcs above and below. There we go. And I need to expand this out some. There we go. So now I just need to get some arcs up here. Okay. And then some arcs down here. Okay, and then I need to flip-flop it without changing the distance at all. We need to get some arcs up here. And then, come on. Go and get some arcs down here. Okay, all right. Now I don't need this again, so I'm going to push that over there since it's not wanting to get rid of it. And then I need to get a line that goes through this point here and this intersection point here. And I know that is a perpendicular bisector. So now I know I have a perpendicular bisector. So what does that tell me? Well, that lets me know that I have 90-degree angles here. So every single one of these angles is a 90-degree angle. Okay, so that helps me with that part. Okay, so that tells me a little bit about some central angles and that sort of stuff. So I need to label the points of intersection. So I'm going to label this one P, and the other one is B. Okay. All right, so I'm going to kind of flip ahead because this is where the lesson keeps going on to page 114, but then we're going to come back to this. So it says, use the definitions to identify the circle parts and answer each question. So identify all the drawn radii of the circle created by the diameter and its perpendicular bisector. All right, so now we got to go back and identify all the radii. Okay, so I'm just going to kind of list them over here. So all the radius. All right, so we have a radius of OP. Okay. Line segment OP, we have a radius of line segment OB, which we already kind of wrote down once. We have a of OB and a line segment of OM. Okay, those are all radii. Okay. All right, so then I'm not going to flip back and forth. You can look on the back side of this. Okay. Then it says what central angles and arcs are produced by these diameter and the perpendicular, and what are their measures. Okay, so I'm just going to kind of work off of here. I'm just going to look at, okay, this radius here, OP, okay, has a central angle here, okay, of so radius OP has an angle of POD, which is equal to 90 degrees because it was a perpendicular bisector, and it has a corresponding arc that is the measure of that arc of PD. So we have an arc of PD, right? Now, again, I'm going to sit here and talk about the next one. So this next one I'm going to talk about is this central angle right here, DOB. Okay, so angle DOB is also equal to 90 degrees, which is equal to the arc of DB. Again, with a little semicircle, so we're talking about this arc right here. And then we just kind of keep working around. We have this central angle right here. That has angle BOM, which is also equal to 90 degrees, which has an arc of BM. That arc right there. And then last but not least, I think I have one more color that I can do. Okay, we can talk about this central angle right here. That is angle MOP, which is also equal to 90 degrees, which is the arc of MP. So we have that one there. Okay? All right. So we have all this stuff going on. Okay? Okay, let's go on. So we've kind of answered central angles. We've answered part B here. Central angles and arcs are produced by a perpendicular, and what are their measures? Explain how we know. Well, it's because it's a perpendicular. Okay, now we need to draw a line through two of our labeled points on the circle to form a secant and a chord. So kind of yesterday you went through some vocabulary. Here's the definition of a secant. So a secant is a line that intersects the circle at 2 points. And it's a line, so it goes through. It doesn't stop. It doesn't have endpoints on the circle. It just intersects the circle. A chord is a segment whose endpoints are points on the circle. Okay, so it looks like the same drawing, and this is why I don't like it. I kind of have the kids erase this part of it so that all they do is identify the chord part of it, which should be this part right here with the endpoints on it. Okay, so that's the difference between it. All right, so we need to form a line through two of our labeled points to form a secant and a chord that is not a diameter. So we're going to go back over here. So we're going to kind of do this as easy as we can here, get some lines going. All right, so I'm going to draw a line through here, so through 2 points. So I'm going to draw a line from P to D. That is my secant, or I mean my chord. All right, so I have chord, which is PD, not CD. So chord PD. So notice it's a line segment. It is not an arc, not to be confused with arc PD. All right, so it's a chord PD. And then I am going to draw a line, which is going to be a secant because it's going to intersect. Where it has arrows on both. Go. Okay. All right, and I'm going to draw a line through it. Let's say a line through MB. Yeah, we'll go through MB here. And that's my secant. Didn't quite go through M now. Let's see if I can. A little bit there. It's a little better. There we go. All right, so now I have my secant is MB. And this again has the arrows on the end. So I know it's not arc MB, I know it's my line MB, and that sort of thing. Okay. All right, so now we've actually kind of drawn some triangles in here. Okay. And we've talked about, or they ask us to use a protractor to measure the angles of the triangle. So let's see if I can get this to work. Kind of a big protractor. And I gotta see if I can. I don't want it bigger. I want it a little bit smaller there. I don't want to move it. I need it. There we go. All right, so we're going to put the center right on the center of the circle, and we're going to end up measuring one of these internal ones here. So let's see if I can get it to rotate for me. Come on. There we go. Come on. Center. And rotate. Okay. All right. Now I want to measure. Oh, that's a 90-degree angle. I don't want to measure that. I want to measure this angle right here. Okay. All right. So I'm going to come over here and I want to measure okay, my protractor is not working for me right now. Okay, so let me try something here. Okay, we're going to put it up on this one here, and we're going to rotate it right here like this, and then we're going to measure. All right, so we're going to take this, and we're going to come up and measure, and it's kind of hard to see, but it's about right at a 45-degree angle. I don't know if all that was worth having that out there. But this is a 45-degree angle in here. There we go. So this one here is 45 degrees, and this one here is 45 degrees. Okay. So we actually have made what is called an isosceles right triangle. Okay. All right, a couple more little pieces of information here. So basically we have a 90 degrees in the center. We have 4, 45, 45, 90 triangles, which are isosceles right triangles. Okay, so again, not much information. Whoops, too far ahead. Okay, not a lot of information on these next pages. The only other thing I want to point out here is there's a little definition here on the major arc and minor arc. Again, a major arc is done with 3 letters, and it is greater than. So a major arc is greater than 180 degrees, and a minor arc is less than 180 degrees. And so you can have a major arc and a minor arc sit there and be complements of each other like they are in this situation, where you have the major arc right here, and that's major arc ACD, that was mentioned right there. And then you have the minor arc, which is its complement, which is this part right here, which is arc AB. All right. Okay, and I think that is about it for the notes. Okay.